This is topic 2.4, which is on biomes, zonation, and succession. Last time we talked about how very, very large ecosystems are called biomes. They occupy large regions of the world, and they're distinguished by their biotic and abiotic factors. So as far as the abiotic factors go, we have latitude, that is where they are in relation to the North Pole, equator, and South Pole. 90 degrees north would be the North Pole. 0 degrees would be the equator. Rainfall, whether it's large or very small rainfall or whether it's seasonal. And then temperature, how temperature fluctuates. And sometimes we'll see that it fluctuates throughout the day. And so if you look over here, you can see basically how the types of biomes break up as far as temperature and precipitation. And we're kind of interested in the extremes that we'll see here. We also should know that not all biomes are terrestrial. A lot of them are out in the water. The ocean is not homogeneous. There's different parts of the ocean. So those are marine biomes. And then, of course, we have freshwater biomes. But mostly we'll be concerned today with terrestrial biomes. One of the distinguishing features about different biomes is that they have different productivity, net primary productivity. That's the amount of production done by photosynthesis, plants, algae, protista, and so forth. And you can see here that desert is way, way down at the bottom there. So productivity is very, very low out there, very fragile environment. Tundra is also. And then as we go over here, we can see that tropical rainforest, as far as terrestrial biomes, is going to be extremely high. But there's also some aquatic biomes that are going to be quite high too. Now, one of the distinguishing features that will determine temperature, of course, is air circulation. Air circulation has to do with its location on the planet. Obviously, the equator, we're going to get hot air. And the tricellular model basically is that there's 3 different circulations of air. The polar cell at the North Pole, the Ferrel cell, which is sort of where we are, 45 degrees. And then you have the Hadley cell at the equator. Basically, warm air is coming up from the equator, cold air is coming up from the polar, and then we get an in-between area of temperate conditions. So let's go ahead and launch into it. I'll describe several features, starting with the 3 conditions I laid out: latitude, temperature, and rainfall, and then I'll add some information here about net primary productivity and something about the biome's fragility and what sort of organisms we might expect. So let's start with deserts. Most deserts are located just up or below slightly from the equator. Equator runs about here, right, through top of Brazil, middle of Africa. We have the big Sahara Desert. That's a great example over here. The outback in Australia, the Kalahari Desert, the Gobi Desert over here in China. So plus or minus 30 degrees. They are distinguished by very hot days but very cold nights because there's very little biotic matter, plants, so forth. There's very little to retain the heat, so it gets very cold at night. And extremely low rain. We wouldn't say just low rain, very low rain. Net productivity is very low because photosynthesis is limited by the lack of water. This is a very fragile food web, as we'll discover later on. If one thing falls, the whole system collapses. Cactus, sagebrush, coyotes, camels, rabbits, foxes, among other things. Then we have tundra. The tundra is probably the next in line as far as lack of rainfall and fragility, and also very low net primary productivity. What are we talking about in tundra? Oh, northern Canada, Alaska, lots of Russia over here. Latitude is quite high north, 60 to 75 degrees. Very cold, obviously. Little rain. We don't consider snowfall to be rain. Not the same thing. And very low sunlight, or what we would call insolation. Moss, lichen, reindeer, Arctic rabbits, polar bears, and so forth. Then we go down to the temperate grasslands. Midwest of the United States, well, not Midwest, but the Dakotas, Kansas, Oklahoma, and so forth. Certain parts of eastern Russia, Kazakhstan, and so forth. Down here is a classic example in Argentina, the Pampas, or what we might call as Patagonia. And you can see that these are areas where you're going to grow a lot of grains, wheat, and so forth. So the temperature, fairly moderate. Kind of cold winters, but hot summers. Moderate, low to moderate rainfall. NPP, therefore, is also moderate. Grasses, very few trees, shrubs, prairie dogs, coyotes, things like that. Open territories, right? Scrubland, or sometimes it's called chaparral. This is not desert. Sometimes it's referred to almost as high desert. What are we talking about here? Well, mostly the Mediterranean. I know it's not listed there, but I would kind of consider parts of Mexico, Arizona, New Mexico, and so forth to be chaparral areas. NPP is fairly low, moderate temperature, not as cold at night as the deserts, but low rainfall. Cactus, deer, rabbits, mouse. Not a whole bunch going there, but beautiful areas. Greece, Italy, Spain. The savanna. Classic example of the savanna is the Serengeti, which is in Kenya and Tanzania. This is located there in the southern hemisphere. Moderate rainfall, but the interesting thing about the rainfall is that you have a dry and rainy season. And that's why you typically have animals that migrate. They're always looking for water. People often get the savanna mixed up with the jungle. They're not the same thing. So when little kids think of animals like elephants and rhinos and lions and so forth, they think they're out in the jungle. No, they're not in the jungle. They're out in these tropical grasslands, which we refer to as savanna. Since they're basically grasslands, NPP is quite high out there. Grass, trees, shrubs. Typically, remember, like in The Lion King, you see that beautiful acacia tree that all the lions are sitting under. Wildebeest, and in particular, you have the famous migration of the wildebeest. Elephants also, gazelles, all animals that do migrations, basically because they're looking for water during the dry season. Then we have our temperate. Temperate means moderate conditions. Deciduous rainforest. Deciduous means trees that lose their leaves in autumn. Hardwood trees, beech, laurel, oak trees, maple trees, things like that. Fair amount of rain. Cold winters and hot summers. We're at 40 to 60 northern latitude. Where are we talking about? Most of Europe, eastern United States, a lot of eastern China. Basically is deciduous rainforests, squirrels, bears, foxes, raccoons. Then we have tropical rainforest. So tropical rainforest means obviously we're down in the tropics. We're near the equator here. Amazon rainforest would be a classic example. A lot of jungles in the Southeast Asia. And by the way, tropical rainforest, this is what we're talking about is jungles. So you can see that's Central Africa is jungle, tropical rainforest, not the same as savanna. Very high temperature, obviously, it's tropical. High rain. Rains almost continuously and near the equator. Nobody is expecting you to remember what the temperatures and the rainfall are. That's why I like to refer it really as just high temperature and high rain. Extremely complex food web, just a lot of going on there. Most species on the planet are located in the tropical rainforest. The highest net primary productivity. Difficult retaining nutrients because it's raining all the time. Things get leached. Rubber trees, orchids, jaguar, tiger. Tiger is not the same as lion. Lion is a savanna animal. Tiger, jaguar, these are jungle animals. And the thing to understand is not only do we find a lot of species down there, but most of the species are stratified. That is, they're up in the upper part of all the trees that we like to call the canopy. And a lot of people believe if you really investigate the canopy of tropical rainforests, there are species that we don't even know exist yet. coniferous forest or a taiga. Sometimes this is also part of the temperate forest. I kind of separated it. Temperate deciduous forest, kind of different trees. Coniferous trees, those are pine trees, noble firs, junipers, things like that. Things that are pretty common out here in Oregon. I know it doesn't have Oregon listed here, but I sort of feel that we're in a coniferous forest. Mostly we're talking about Siberia, though. Lower tundra area and so forth here. Moose, elk, a lot of Canada is kind of like that too. Moderate temperature. Our winters never get super duper cold, but summers don't get super hot, although lately we're having some extreme temperatures. Rainfall is kind of low. Now I know people think where we live here in Oregon that it rains all the time. Yeah, it's kind of a continual gray misty, but we don't have a whole bunch of hard rainfalls. And actually, if you look at our average rainfall over the year, it's actually less than most of the United States. Kind of funny. NPP is fairly low. Our soil is not particularly great for growing things. That's why we have pine trees and so forth. They can kind of grow in sandy, non-loamy sort of soil. So that's terrestrial. Let's look now at things out in the ocean. So the one I want you to know really is tropical coral reefs. Caribbean would be a great example here. South Seas would be a good example. Obviously near the equator, it's tropical, so the water is pretty warm. Lots of sun, high insolation, lots of biodiversity, and high NPP. Now I know people forget. They think, oh, net primary productivity, that's grasses and so forth. But remember, there's a lot of organisms out in the ocean. Most of photosynthesis is actually being done by organisms in the ocean, not on land. Plankton, algae, seagrasses, sea urchins, sponges, and then you have larger animals, sharks down there. Within biomes now, we can have sub-areas. We call those sub-areas zones. And so if you start at one end of biome and walk across it, well, maybe not walk across it, but travel across it, you will see different zones as you go along. And the reason is many of the conditions are changing. So there's a gradient that we call zonation. What are the reasons? The amount of sunlight, the niches, temperature, rainfall, altitude, soil, other sorts of interactions are changing as you move across the zones of a biome. Let's take a look at some examples here. How about just mountains? So I'm thinking here, if I was at Mount Hood, for example, you start at the bottom, you always see lots of trees and so forth, and as you get higher and higher, the trees disappear. There's our tree line. And it's almost sometimes as if somebody just drew a line on the mountain and said, okay, no more trees at this point. You get to smaller plants, grasses, and so forth, and then suddenly you don't even see that. As you get higher, the altitude, right, gets colder up here. We get very, very low-level life, mosses, lichens, things that really can only exist on bare rock. And finally, you just get to bare rock. So within this biome here, and this might be a temperate forest, but the zonation changes as you move across it. Same thing goes on out near the beaches. So if we look at coastal areas, here's a rocky zone, right? So up here on the top there, we have a splash zone. This is where waves are crashing in. So you have a certain amount of life going on here. Then as you get into the tidal zone, tide is going in and out, and you see other types of animals here. For example, one of the things I noticed when I go out to a tidal zone is you see starfish. And the starfish move around. The starfish actually can be different colors depending on where they live in the tidal zone. Then when you get down here where there's less action going on, you get plant life and so forth that can take a hold. So as we go through the tidal areas, that is the abiotic factor which is determining the zones of this, well, I wouldn't say biome, but ecosystem here, and you get different types of life going on there. What we're looking at here is try and determine what the abiotic factor is that is determining what type of zones you would have within an ecosystem. Let's look at one more. Now we're out in the deep ocean here. So the ocean is actually divided into areas. Very low ocean is benthic. Way out in the middle of the ocean is pelagic, and then we have the coastal areas. And it's very interesting that once you go out into the deep ocean, there's not a whole lot going on out there. A lot of people think, oh, if you just jump off a boat in the middle of the ocean, there's all these fish and things. There isn't. It's almost a desert out there. It's pretty quiet. So the depth of the ocean then would be the abiotic factor, which would be determining what sort of life we see out here. Now, how do things change then? So what caused this zonation? So the changes are referred to as succession. This is long-term change in an ecosystem. What happens here is that we start off with primitive life. I don't want to say primitive life, but things that can survive without a lot of factors. That would establish a pioneer community. And these are going to be very hardy things that can live on rock, things that don't need very good soil. Then finally, it's going to change into a climax community where you get much bigger plants, better soil, things that are larger. So, for example, bare rock, nothing growing there. First guys to come in there, colonizers, pioneer community. Lichen. Lichen is a symbiotic relationship which can actually exist on rock. Moss. Moss is a very primitive plant that doesn't have roots, so it doesn't need to embed itself in a lot of good soil. Then you start to get a vascular plant, ferns, right, which catch water. Then finally we get traditional rooted plants like small shrubs, which finally give way to trees. So if you go back here for a moment and look here, you can see what must have happened as we go down the hill here. We had succession. We started with lichens, small bushes, and then finally we get trees down here. Now, for those of us who live up in Oregon, we can visit Mount St. Helens, which blew its top in 1980, wiped out the whole area, and then little by little colonizers came in there. So you had lichen, moss, and so forth, which broke up the rock, which started to make soil and put nutrients into the soil, and little by little that allowed bushes to come in, and finally, if you go up there, it's been over 40 years now, you can start to see trees have really recovered in the area. Now, there's two different ways we can think about succession. There's primary and there's secondary. Primary means we're starting to build up an ecosystem on an area which never had one before. Let's suppose, like in my Mount St. Helens example, volcano wiped out the whole area there. Nothing there, brand new land. The guys who come in there would be primary succession. Same thing happens if you go out to Hawaii, where a volcano is spewing lava. I went out to the Big Island of Hawaii, saw that happen there, brand new land. Nothing out there. This would be primary succession. Secondary succession means there's still things, remnants, that are recovering there, and so you're not starting from zero. A hurricane comes through an area, a fire comes through an area, but it doesn't wipe out everything, and there's still a lot of goodies in the soil. It recovers a lot faster. This would be called secondary succession. So we're going to go through stages, right? First of all, we have colonization. These are guys who can come in and grow on bare rock. Then we have establishment. These guys will start to break up the rock and form soil. Stage 3, then we have competition. Larger plants start to come in here and they try and get established. Stage 4, stabilization. You start to create other factors such as shade, sunny areas, areas that maintain a certain temperature, and you start to build complex food webs, and finally you reach a steady state. It tops off there, and it looks like a climax community. This looks very much like the population curve we really had, or an S-shaped curve. Could probably have the same idea here. So let's go ahead and compare a pioneer community with a climax community. So we're starting in a pioneer community, and we go to a climax. So let's look at the gross primary productivity. Well, it would be very, very low because these guys are using all their energy to maintain themselves. Now, their net productivity is very high. They're producing a lot. They're growing, right? But they are consuming a lot too. Very few niches here and very, very low diversity. And then, of course, it would be the opposite when they finally grow. And the reason why net primary productivity would be low over here is, remember, now you have bigger things, animals and so forth, that are doing secondary primary, not secondary, but net secondary productivity. Sorry about that. Let's just sum it up here, right? Production versus respiration. So production means what are you building as far as biomass? Respiration means what energy are you using up to maintain yourself? If you're producing a lot more than you're using up, greater than 1, then things get bigger. We're moving along succession. If you're producing a lot less than you're using up, then you're using up your biomass. Things are getting smaller. That's no good. And at the top of it, we reach a steady state where everything is balanced. It's sustainable. You're producing exactly as much as you're using up in respiration. Okay, who are the guys who are going to take advantage of this? Well, if there is a stable environment, you have guys who we refer to as a K strategy. If you have an unstable environment, the guys are referred to as an R strategy. So different animals, plants, occupy an R or K strategy. Sometimes in between is referred to as C or an I strategy. So who are R strategy guys? They're the ones who initially come in. So they're in primary succession. And then K guys are the ones who after time come in and dominate. So we might say that lichen would be an initial colonizer, and an oak tree might be a K strategy dominant species. R strategy, these guys have short life. They reproduce extremely fast. You have to, because you can't wait for good conditions. You got to go for it. They tend to be small. They reproduce in large numbers, and they work best when they don't have to rely on the environment. Let's use an example here. So how about an elephant? Would an elephant be an R strategy or a K strategy? Well, an elephant out in the savannah is a very big, it's large, dominant species, kind of top. Nobody's going to mess with the elephant. They have a very long life. They develop very slowly. Can't remember what their litters are, but fairly small. And they thrive in a stable environment. In contrast, how about a mosquito? So a mosquito, fairly short, large numbers they reproduce. They reproduce very rapidly. They don't have to wait every year and so forth. They just go for it. Short life. I don't know exactly how long they live, but it's pretty quickly. The reason why, again, different animals and plants for that matter, adopt different strategies is to be successful in their environment. And there's 2 different ways you can be successful. You can say, I'm just going to go with the volume method, reproduce a lot of offspring and hope some of them survive. Most of them won't, and that'll help me continue my line. Or your strategy could be, I'm not going to reproduce very often, but I'm going to live for a long, long time and just wait for the perfect conditions. And that will reproduce and maintain their line also.